So on example 6, it's like a two's clues problem. You'll quiz tomorrow, by the way, over example 4, 5, and 6. But six appears to only give you one clue, right? The point negative 4, 3, negative 4, 3. So it says the terminal side of theta passes through that point. You're going to see that this type of question is actually less fun than the other type. If I go to the point negative 4, 3, 1, 2, 3, 4, 1, 2, 3, that puts the point right there. Okay? That means that the terminal ray passes through that point. So it looks like that. So my angle theta must be this right here. There's theta. Now remember, I need to create a triangle by dropping a perpendicular from any point on the terminal ray. Is there one point that's well suited for dropping a perp from? Yeah, how about negative 4, 3? If I drop the perp down to there, I create this little reference triangle. And now, because it is a coordinate, it puts me into quadrant 2. I don't have to use a second clue to figure out which quadrant it's in. I know it's in quadrant 2. And notice it also gives me 2 of the 3, excuse me, it also gives me 2 of the 3 side lengths. This is negative 4, and this is 3. So it's a double clue. It gives me 2 of the 3 sides, namely the x and the y sign, and it gives me the quadrant automatically based upon the coordinate. All right, so now how do we find the third side, which is the hypotenuse? X squared plus y squared equals r squared, the Pythagorean theorem. And we plug in negative 4 squared plus 3 squared equals r squared. So r squared must equal 16 plus 9. R squared equals 25. And when I take the square root of r, I consider plus or minus. Which one do I want here? Plus. With r, I always want plus, right? So I'm going to go ahead and label that side. That's your old 3, 4, 5 right triangle. You may recognize it now. It's a Pythagorean triple, we call it. 3 integers that satisfy the Pythagorean theorem. All right, now that I have all 3 sides, I have all 6 trig functions. Your quiz tomorrow will not involve one that's this easy. Your quiz tomorrow will be more like example 5, or example 4, or even example 3. More like example 4 and 5. Your quiz tomorrow will be more like example 4 and 5. Okay, the true two's clues problems. All right, now let's go ahead and list our ratios here. So we got sine of theta. Sine is y over r, so that's 3/5. Cosine of theta is x over r, that's negative 4/5. Tangent of theta is y over x, that's going to be negative 3/4. And then the reciprocal functions, cosecant is r over y, so that's 5/3. That's the reciprocal of sine. Secant of theta is r over x, that's 5 over negative 4. That's the reciprocal of cosine, that looks good. And then cotangent of theta is x over y, that's negative 4/3. And that is, in fact, the reciprocal of tangent. So again, get in the habit of pulling all your ratios off the triangle, and then that second column, just compare them to the first one and make sure they are the flipped version. No radical here. Excuse me. There's no radical here, so there's really no radicals to clean up. So that makes it easy. All right, now the last thing we want to do is we want to find the angle theta, and we want to find the reference angle. The reference angle is this right here. There's the reference angle. I'll draw a little arrow to it. There's theta ref. So I need the calculator. Let me go ahead and pull the calculator up here. I'll use my old faithful Minnesota. I almost said Wisconsin. No offense to Minnesota. They're all the same, all those northern states. Yeah, Minnesota, Wisconsin. They're the same. They have the same governor even, I think. Not really. Yeah, let's take a look. Yeah, we get to choose. Since we've been doing it in degree, let's just for now stay in degree. It's a little more intuitive to stay in degree. If we need to convert it to radians, we know all we have to do is multiply by pi over 180. So what's the first thing we do? We check our mode, right? Go to mode and check down there where it says radian degree. Radian is highlighted, right? We were taking a test yesterday in calculus, and they had sine and cosine and tangent on their test. And they were picking up some of the calculators that y'all had used in first and second period, and they were getting wrong answers, and they were getting frustrated. And I was like, you guys didn't check yourself before you wrecked yourself, did you? They were in degree mode and they were supposed to be in radian mode, and they didn't check. So luckily, I gave them a little hint. But it's your obligation to check to make sure you're in the right mode. If we want to be in degrees, we have to manually switch it to degrees, okay? Whenever you reset your calculator, it defaults back to radians. All right, so let's choose one of these three. Which one do you want to choose, sine, cosine, or tangent?
Sine.
Let's choose sine. All right, so to get a check, you're going to have to show me theta equals inverse sine of 3/5. That's the very least you have to show me. That's taking sine of theta equals 3/5 and then taking the inverse sine of both sides. So that's going to earn a check. Now we go to our calculator and we type in second sine. Oops, my calculator freezes up very regularly. Second sine of 3 divided by 5. And it tells us that theta is 36.869. Is that our angle in quadrant 2? It's not. It's actually not even coterminal with it, right? Where does 36.869 live? In quadrant 1. And where does my angle live? In quadrant 2. We know that they have the exact same what angle? They have the exact same reference angle. Yeah. Now, because this is already a positive acute angle, what's the reference angle for an angle that's 36.869? 36.869. Whoops. Yeah, so I'm going to go ahead and say the reference angle is 36.869. We actually found that first. All right. Now, using your diagram, we can figure out how to find theta. You just work off the x-axis. If the x-axis is 180 right here, and this angle here is 36.869, how do we figure out what theta is?
180 minus.
180 minus. Now, I want you to show that. I want you to say 180 degrees minus theta ref. You're going to get a check for the reference angle. You're going to get a check for your method. This tells me your method. It tells me what you're doing. So now, since my reference angle is already showing, I just do 180 minus, and I'll hit second negative. You could store it as A if you want. I'm just going to hit second negative, which recalls the answer from the previous line. And we don't ever use a rounded number for an intermediate calculation. I get 143.130. Do I need that last zero?
Yes.
I do. It's part of the accuracy degrees. You'll get a check for that. Second negative recalls the answer from the previous line. Yeah. See how it says ANS, answer? The other way to do it is we did this like this. If you think you're going to use it more than once, store it as alpha A. Like that. And then you can just do 180 minus alpha A. And you get the same answer. And then if you want to know what A is, you can just hit alpha A, and there it still is. You don't have to go back and recalculate. It stores it with all the decimals. So that's a good habit to get into. All right. So that was a little bit easier than a two's clues problem. Yeah. But it's another type of problem you can see. All right. Comments, questions on number 6? All right. Let's move on then. I've already given you this definition, but here it is in a box, right? When it's in a box, that means it's more formal, and it could be donuts. I don't think this one's donuts. It is special, though. A quadrantal angle. A quadrantal angle. The accent is on the A. Not if the accent were on the second A, that'd be kind of a hard number. A quadrantal angle. That's kind of harsh, isn't it? Quadrantal. It's not quadrantal. It's a quadrantal. A quadrantal angle. It's an angle that terminates on either the x or y axis. Okay. It's an angle that either terminates on the x or y axis. So if you want to know what they are, 0 degrees, right? 90 degrees, 180 degrees, 207 degrees, and then coterminal, 360 degrees. And then all of the angles that are coterminal with those 4 guys, right? And of course, you can also do it in radians. You can do 0 radians, pi halves radians, pi, 3 pi halves, and 2 pi. So all the angles that are coterminal with those guys. Those are your quadrantal angles. What do we know about the reference angle if our angle terminates on one of the axes? What's the reference angle? Well, let's say that I have 360 degrees. Is there even a perpendicular that I can drop to the x-axis if I'm on the x-axis? No. Okay. So the reference angle is D and E. Theta ref is D and E. Remember, the reference angle has to be positive and acute. Acute means strictly between 0 and 90. It can't be 0, can't be 90. If you want to get technical here, the reference angle would be 0, right? Because there's nowhere to go. We're already on the x-axis. But 0 is not an acute number. What if it was 90 degrees? If I drop the perpendicular straight down to the x-axis, it's straight down the line, right? what would the angle to the x-axis be? It would be 90 degrees. But is 90 degrees an acute angle?
No.
No, it's not. So the reference angle would still be D and E. So anytime you have an angle that terminates on the x or y axis, there is no reference angle and there is no reference triangle. There is no reference angle and there is no reference triangle. Now, that doesn't mean that we can't figure out the 6 trig functions for each of them. Okay, they're going to be exceptional. All right, let me show you what I mean here. All right, so let's go ahead and draw 0 degrees. I'll draw it in green. Here's 0 degrees. Let's go ahead and say that we're out here. We're going to drop a perp from any point on the terminal ray. Let's just use the point 1, 0. That's a real convenient point to use on the terminal ray. Would you agree? Yeah. So x is going to be 1, y is going to be 0, and guess what the radius is going to be? It's also going to be 1. Yeah. If I were to continue that point all the way around, I would get what's called the unit circle. The unit circle is basically a circle that's centered at the origin whose radius is 1. So I have all of my values that I need for my 6 trig functions. X is 1, y is 0, and r is also 1. All right, let's go ahead and list our 6 trig functions. Sine of theta, when theta is 0 degrees, it's y over r. What's y over r in this case? I'll write it out. What's y over r? It's 0 over 1. What's 0 over 1? 0. Yeah, it's 0. 0 divided by any non-zero number is 0, right? 0 divided by 1 is 0. 0 divided by negative 1 is 0. 0 divided by 5 is 0. Now, instead of putting theta there, let me actually do better than theta. We know what the angle is. It's 0 degrees. So what's sine of 0 degrees?
0.
0. Is that ever going to change? Is it going to one day be another number, or is it always 0? It's always 0. Here's a way to remember that sine of 0 is 0. 0 lands on the x-axis. What's the y-coordinate on the x-axis? 0. Sine, y, height. It's the height of the triangle. What's the height of the triangle when the triangle's been collapsed down vertically to the x-axis? What's the height?
0.
0. Sine, y, height. The height is 0. The y is 0. The sine is 0. Sine, y, height. All 0. Got it? Good. What would cosine of 0? Oh, that almost put me in pep rally mood right there. Oh, yeah. What's cosine of 0? Well, cosine is x over r.
So
The x-coordinate is 1. The r-coordinate is
1.
1. What's 1 over 1? 1. Guess what cosine of 0 always is, always will be? 1. Never not 1. Cosine of 0 degrees is always 1. Guess what cosine of 360 is?
1.
It should also be 1, right? Because it terminates at the same place. It's coterminal. It's going to have the same lack of a triangle. Yeah. So coterminal angles, as we saw yesterday, have the same trig functions. All right. What's tangent of 0 degrees?
0 over 1.
It's y over x, which is 0 over 1. What's 0 over 1?
0.
0. Yep, yep. I'm going to keep working straight down now. What would cosecant of 0 be? That's r over y. What's r over y?
1 over 0.
1 over 0. Now, what happens if we get a 0 in the denominator?
DNA.
It's d and e. You can't divide it by 0. It's some type of infinity. That's why it doesn't exist. We don't know if it's positive infinity. We don't know it's negative infinity. But remember, graphically, non-zero over 0 means a vertical asymptote. The graph would have a vertical asymptote at 0, and on either side it can go up to infinity or down to negative infinity. All right, what would secant of 0 be? That's r over x. That's going to be what? 1 over 1. What's 1 over 1? 1. Guess what secant of 0 always is? It's always 1. All right, and then the last one, what's cotangent of 0 degrees? Well, that's x over y. What's x over y?
1 over
1 over 0, which is, of course, what? No,
DNA.
d and e. The graph of cotangent is going to have a vertical asymptote there as well. And again, it's some type of infinity. Anytime you get d and e here, because you get non-zero over 0, it's some type of infinity, so we just say d and e. The value doesn't exist. Okay, guess what? You're going to have to know these. If you want to memorize them now, you can. Eventually, we're going to start quizzing every day, and I'm going to give you 10 minutes to start with to answer 10 of these. And one of the questions might be cosecant of 0 degrees, and you're going to put d and e. I might ask you for secant of 0 degrees, and you're going to say 1. We're not there yet, though. Right now, we're just listing them. Okay, let's look at 90 degrees. Okay, 90 degrees is straight up, right here. There's the terminal ray. What's a convenient point to use on the terminal ray?
0, 1.
0, 1. Very good. So my x is 0, my y is 1 now, and my radius is also what?
0.
No,
1.
1. Yeah, the radius is still 1. If I choose the point 0, 1 and 1, 0, and yeah, it'll always be 1 if you choose those points, right? Because that's how far it is from my point at the origin to the point that I chose. It's 1 unit. Just think of that as the little arrow that when I rotate around becomes the radius of that circle, okay? So now we have all 3 letters. We should have all 6 trig functions. Yeah? Let's list them. Sine of theta, I'm not going to put the definition anymore. It's y over r, that's 1 over 1, that's what? 1. Now, think about that. When you're up at 90 degrees, you've collapsed the triangle down horizontally to nothing. The width is nothing, right? The width is nothing, and the height is stretched out to a maximum. Guess what the maximum height of these triangles can be? 1. So what's sine of 90 degrees? 1. What's the height of the triangle when it's collapsed down horizontally to nothing? 1. So the sine y height is 1. Now, if we've collapsed it down horizontally to the y-axis, what should the width of the triangle be? It should be 0. Cosine measures the width, remember. Let's see. What's cosine? It's x over r. That's 0 over 1, which is, in fact, 0. Excuse me. Wow, big cough. So when you're on the x-axis, the cosine value is at a maximum, which is 1, and the height is at a minimum, which is 0. When you're on the y-axis, you've collapsed the triangle down to nothing horizontally, so the width is 0, the cosine is 0, and the height is a maximum of 1. Does that make sense? All right, it should. If you're thinking it should. Tangent of theta, that's y over x. What's y over x? That's 1 over 0, which is what?
DNE.
DNE. It's in the game, right? Actually, it's not in the game. It doesn't exist. Yeah, EA Sports. Cosecant is r over y. What's r over y? 1 over 1, which is 1. What's secant of? I'm putting theta there. I should probably just do what? We know what theta is, right?
90.
It's 90. Yeah, let me just put 90 in there.
I was going to ask, but
Yeah, no, we could put theta. As long as I would have to come up here and put theta equals 90. We should just put 90 in there. I'm just used to putting theta. Secant of 90, that's r over x. R over x is 1 over 0. Guess what that is?
DNE.
DNE. And then finally, we'll finish out this little section with cotangent of 90 degrees. Cotangent is x over y. That's 0 over 1, which is
1.
0. 0 over 1 is 0.
Oh, that's right.
Right? 0 in the top only is always 0. 0 in the bottom at any time is DNE. All right. Now, let's look at 180. 180 degrees. That's going to be straight over here. What's a good point to choose on the terminal array for 180?
-1, 0.
-1, 0. So there's your x, there's your y. And what would the radius of rotation be if I go out to -1?
1.
The radius would still be 1, right? That would give me another circle if I rotate all the way around whose radius is 1 unit. So r is 1, x is now -1, and y is 0. So let's go ahead and do the sign. What should the sign be if we've collapsed the height down to nothing on the x-axis?
Nothing.
It should be 0, right? Nothing is 0. Let's try it. What's y over r? That's 0 over 1, which is what?
0.
0. It makes sense. We've collapsed the triangle down onto the x-axis. There is no height. Now, because there is no height, the width is at a maximum, which has a magnitude of 1. But because it's in quadrant 2, or on the verge between quadrant 2 and 3, it's not 1. Guess what it is?
Negative.
It's -1. It's x over r, which is -1 over 1, which is -1. So the magnitude is still a maximum of 1, but because of the orientation of it, it's going to be negative. All right, what is tangent of 180? Tangent of 180, that's y over x. Y over x is 0 over -1, which is what?
Still 0.
Still 0. Yeah. Still 0. All right, let's do the reciprocals now. Cosecant of 180 degrees, that's r over y. So that's 1 over 0, which is what? DNE. What is secant of 180 degrees? Well, that's r over x. That's 1 over -1, which is -1. Yep. And what is cotangent of 180? X over y, which is negative 1 over 0, which is d and e. So have you noticed so far that when we've looked at these quadrantal angles, two of the trig functions have been d and e every time? Yeah. And then we've just oscillated between zeros and ones. Now, here's another way that you could think about it. Sine is the reciprocal of cosecant, is it not? So if sine is 0, the cosecant should be what? What's the reciprocal of 0? Nope.
Does not exist.
Does not exist. The reciprocal of 0 is infinity, and the reciprocal of infinity is 0. And the reciprocal of 0 is infinity because the reciprocal of infinity is what? 0. So if sine is 0, its reciprocal cosecant should be what?
Infinity.
D and E, right? Infinity. We'll say D and E because we don't know if it's plus or minus infinity.
Okay.
Or on the flip side, if cosecant is D and E, what should its reciprocal sign be? 0. You got it? Now watch this. Cosine and secant are also reciprocals. So if cosine is negative 1, guess what the secant is? It's the reciprocal of negative 1. And guess what the reciprocal of negative 1 is? It's still negative 1. All right, watch. I'll show you. If I let negative 1 equal negative 1 over 1, and then I flip it, there's a symbol for flip it, I get 1 over negative 1, which is still what? Negative 1. Negative 1 is its own reciprocal, and so is 1. Okay? Negative 1 and 1 are their own reciprocal. So if you know the cosine is negative 1, you know the secant is what? Negative 1, inverse of isa. And look at this. Look at this. Tangent is the reciprocal of cotangent. So if tangent is 0, guess what its reciprocal cotangent is? D and E. Yeah, very good. You see how that works? Let's see if that works over here. If cotangent of 90 is 0, what's the reciprocal of cotangent? Tangent, right? And it should be D and E.
Oh, yeah.
If cotangent is 0, its reciprocal tangent is D and E, right? And if secant of 90 is D and E, what's the reciprocal of secant? Cosine. And what's the reciprocal of D and E? 0. Got it? If sine is 1, what's the reciprocal of 1? 1. It's its own reciprocal. So if you know any of the three, you can get the other one easily just by using the reciprocal. Okay? And you just got to remember the reciprocal of 0 is D and E, and the reciprocal of D and E is 0. You also got to remember the reciprocal of 1 is 1, and the reciprocal of negative 1 is negative 1. If you got that, then all you need is 3. The others come for free. See how that works? Let's try that on 27T, okay? 27D. 27D is 3/4 of the way around. Okay, 3/4 of the way around. That's going to be down here. The ordered pair that we're going to use to draw our perp from is 0, negative 1. So there's your x and there's your y. And of course, the radius would still be 1. Okay, we'll just go all the way around from that point. Create the circle whose radius is 1. So now we know all three. So sine of 270. What's sine of 270? Negative 1. Let's go right away and do its reciprocal. What is cosecant then of 270? What's the reciprocal of negative 1? Negative 1. Aha. Now we can list them in reciprocal pairs. Okay. What's cosine of 270? Well, that's x over r. That's 0 over 1, which is what?
1.
No. Remember, if we land on the y-axis, we've collapsed the triangle's width down to 0. Cosine measures the width is 0. So what should the secant of 270 be?
Yeah.
D and E. Hot diggity donut. We got it. And then finally, we'll figure out what tangent of 270 is. Tangent's y over x. That's negative 1 over 0, which is what? D and E. So the reciprocal of tangent, which is cotangent of 270, must be the reciprocal of D and E, which in this case is what? 0.
Woo.
You're figuring it out? You see how this works? This is how the unit circle works. Possibly, yeah. No, I'm just going to give you a Two's Clues problem tomorrow. We need to move on, so I don't want to quiz you over too many things. Now, what about 360? 360 is coterminal with, here's the symbol for coterminal, remember? It's coterminal with 0. So if I were to draw 360 and drop a perp from the point on there, wouldn't it be the same as what I did for 0? So guess what I can do? This is nice with notability. I can just copy everything I did for 0 and paste it over here under 360, and then just come in here and change all the angles from 0 to 360. 360, 360, 360, 360, 360, 360. There you go. It's not going to be any different, is it? No different, because it terminates at the same place. Let's say that again. Coterminal angles have the same two things. Number one, the same reference angle. And number two, trig functions. Coterminal angles have the same reference angle and the same trig function. So what about 720? The same thing, right? The same thing. Because 720 terminates at the same place. So I'll do that, and then I'll just write. I'm too lazy here. I'm just going to put 720, 720, 720, 7. I'm not going to erase 720. You get the idea, right? 720. Yeah.
I just put an arrow.
It's the same as 360. It's the same as sine. I just got to change the angle measure. What about 1080? Where is 1080 coterminal with one of those? What's 720 plus 360? It's 3 rotations. So I'm still landing at the same spot, aren't I? So it should be what? The same, except now it's going to be 1080. 1080, you get the idea. 1080, 1080, 1080, 1080. Sweet. Caroline. Woo, woo, woo. If you know it for one of the angles, you know it for infinitely many other angles that are coterminal with it. Pretty nice, isn't it? Now with notability, it's really nice. Back in the day when we didn't have notability and we were taking notes by hand, students would be like, cramp, cramp, cramp. They'd be cramping up in their hand at this point from all of the copying. All right.
Copying.
Copying. Yeah, copying. Now, the circles that we used in each of those examples, A through E up above, those were called unit circles. Okay? What is a unit circle? I will tell you right here. A unit circle has two characteristics. Number one, it's centered at the origin. All of our little dotted line circles that I drew were centered at the origin. And then the second aspect is, guess what? They have a radius equal to 1 unit, whatever that is, feet, miles, inches, yards, meters, kilometers. It's 1 unit long. Okay? And that worked for us too because that was the most convenient point to drop our perp from. There really was not a perp to drop, but it was the easiest point to use on the terminal array. Okay? So what's a unit circle? Two characteristics. Centered at the origin, radius of 1 unit. That's why we call it a unit circle. Okay. We are going to memorize all 6 trig functions for a slew of angles as we rotate around the unit circle. We're going to memorize them for all of the quadrantal angles, all 6 trig functions for all the quadrantal angles, plus all of the trig functions for your special right triangles from geometry. Remember your special right triangles from geometry? There were 2 of them. You had your 30, 60, 90, and your 45, 45, 90. Okay? So let's go ahead and see what the trig functions are for each of these. Okay? For the 30, 60, 90, and the 45, 45, 90. Okay, so let's start with the 30, 60, 90. Go ahead and draw yourself a 30, 60, 90 triangle. Here's your base. A 30-degree angle is pretty shallow. And then you drop a perp down, and you get yourself a little triangle that looks like that. There's the right angle, right? So the smallest, opposite the smallest side should be the smallest angle. Opposite the hypotenuse is your 90-degree angle. And opposite the medium length side is your medium angle, which is your 60. Do y'all remember, y'all should have memorized in geometry, do y'all remember the unit side lengths for any 30, 60, 90 triangle, from which all others can be obtained by dilation, similar triangles? Something square root. It's a good start. I want to label all 3 sides as lengths. Y'all should have had to have memorized the unit side lengths for a 30, 60, 90. You can't get out of algebra without memorizing the quadratic formula, and you can't get out of geometry without memorizing the unit side lengths for your two special right triangles. How did they let y'all out of there? How did y'all escape? That's not an excuse. If you learned it, you learned it. No. It involves 1, a 2, and a 3, but not 1, 2, 3. You're getting it. See, we're jogging your memory. It involves a 1, 2, and a 3, but not quite a 1, 2, and a 3. Oh, you're memorizing it off the table, or it was x square root of something, x times something, x. That's fine. We'll let x equal 1 in this case. Well, let me give it to you now, and then you don't ever forget. I'm going to come to your house in 80 years and knock on your door and be like, hey, tell me what the heck's the ruckus. Can I use your restroom? Opposite the smallest angle, which is your 30-degree angle, you assign a unit length of 1. Okay? Because you don't want things to be fractions. So you establish the smallest side to be 1. Okay? Then we're going to have the next side length is going to be not 3, but the square root of 3. That's opposite the middle, square root of 3. Remember that? And then the hypotenuse is the largest side, it's a 2. So it's your 1 square root of 3, 2. 1 square root of 3, 2. Okay, so your 30, 60, 90 has proportion lengths of 1 square root of 3 and 2 in increasing order. You should remember that. Now, on your formula chart, it was always 2x, 1x, square root of 3x, and x could be any number. That's your scale factor. You can make this triangle bigger, or you can make it smaller. Okay? We're going to make it smaller. You know why? We're going to let x be a fraction, because what I want to do is I want to take this side right here. I want to take the radius, which is your hypotenuse. This equals r, right? It's a hypotenuse. And this is x, and this is y. Yeah, I want to put it on a unit circle. So I want to scale this triangle down, not so the smallest side length is 1, but so that the largest side is 1. I want to make this a 1. So what would I need to multiply all 3 sides by to make it a 1? 1/2. I want to make it half as big. So I'm going to redraw it. Okay, I'm going to redraw it half as big. In other words, if you want to think about it this way, I'm going to divide all 3 sides by 2. That works, right? It's like multiplying by 1/2. So let's do the hypotenuse first. What's 2 divided by 2? 1. That's going to fit nicely on my unit circle now, because my radius is 1. What's 1 divided by 2? 1/2. I'm going to leave it as 1 over 2, okay? And what's the square root of 3 divided by 2? Square root of 3 over 2. Yeah. We'll just leave it like that. So what I have now is a little bit smaller triangle, but it fits perfectly on a unit circle, okay? Now here's what we're going to do. We're going to put 30 degrees as our central angle on the x-axis. Remember, you didn't do this in geometry. You just left your triangle floating around in space. And that's why you had to use SOHCAHTOA carefully, because SOHCAHTOA was always in reference to your reference angle. If you were referencing the 30 degrees, the opposite would be a half. But if you were referencing the 60 degrees, the opposite would be square root of 3 over 2. The opposite and the adjacent change based on your reference angle. When we put it on the coordinate plane, there is no arguing what the reference angle is now, right? The reference angle is 30 degrees, not 60 degrees. Would you agree with me on that at this point? Okay, good. So the reference angle is 30 degrees. So we can still use SOHCAHTOA, but we don't need to. Let's go ahead and list all of them. Okay, this is your x. Oops. Let's do it this way. This is x, this is y, and there's r. So let's what's that?
Why is that your y?
Oh, I labeled them backwards. Thank you. Yeah. Can I use your restroom? I've lost a little bit of my mental acuity. I think I was pretending like I was 80 years from now going to your house, and I got my x's and y's backwards. That must be it. No, the answer to that is careless mistakes are easy to make when you're not thinking. Okay. So let's do sine of theta. Sine of theta is y over r. That's 1/2 divided by 1. What's 1/2 divided by 1? 1/2. Now, if we did that using SOHCAHTOA, would that also work? If in my original triangle, if 30 degrees is my reference angle, the opposite is 1? Yeah, and the hypotenuse was 2. What's 1 over 2? 1/2. We're just doing it a little bit differently now. We're saying it's 1/2 divided by 1. What's 1/2 divided by 1? 1/2. So guess what? Irrespective of the size of the triangle, whether it's a big one or a small one, or medium small or medium large or extra medium or extra extra large or extra petite tiny small, guess what the sign of, I better not put theta in there again. We better make it specific. What would the sign of 30 degrees always be? Always. Never, not always.
1/2.
1/2. Sign of 30 degrees is never not 1/2. It's always 1/2. Always has been, always will be. Got it? All right. What would the cosine of 30 degrees be? Well, that's x over r. That's square root of 3/2 divided by 1, which is what? Square root of 3/2, right? That works in the SOHCAHTOA up above too. If you look at SOHCAHTOA, adjacent over hypotenuse in the original, the adjacent is the square root of 3. The hypotenuse is 2. We're just getting it a little bit differently. We're doing square root of 3/2 divided by 1, which is itself. Guess what the cosine of 30 degrees always is? Square root of 3 over 2. Now, which number is bigger, 1/2 or square root of 3/2? Uh-uh.
No.
If they both have a denominator of 2, all you got to do is compare their numerators, right?
Square root of 3 is bigger.
Square root of 3 is bigger, right? Square root of 3 is bigger. So this triangle is wider than it is tall. Would you agree?
Yes.
It's wider than it is tall. So the cosine ratio should be a little bit bigger than the sine height ratio. Would you agree? You have to. You have to agree unless you want to be wrong. 30 degrees is a very shallow angle. We're not that far off the x-axis. When we drop a perp for 30 degrees, because it's a shallow angle, our horizontal measurement is bigger than the vertical measurement. So the cosine is square root of 3 over 2, and the height, sine y, is 1 over 2. It's smaller. Got it? That's super important to understand as we kind of ramp up the unit circle idea. All right, let's do tangent of 30 degrees. Tangent of 30 degrees. That's y over x. What's y over x?
1/2.
1/2 over,
Square root of 3 over 2.
oh my Jiminy Crickets. I have myself what's called a complex fraction, don't I? Well, let's do stay, change, flip. Stay, 1/2 stay, keep, whatever you learned it as. Change division to multiplication. And instead of dividing by square root of 3 over 2, we'll multiply by its reciprocal, 2 over the square root of 3. What do you notice about the 2's? They do what? Did you say cancel? Oh, thank you. They divide out. They don't cancel. They divide out. Will that always happen?
No. Yes.
Yeah, it will.
Yeah.
It will always happen. The 2's will always divide out, and we're left with 1 over the square root of 3, which if I rationalize by multiplying by root 3 over root 3 becomes what?
The square root of 3 over 3.
Yeah. Guess what the tangent of 30 degrees is always going to be? Never, not always. Square root of 3 over 3. Always. Tangent square root of 3 over 3. Always has been, always will be. All right. Let's go ahead and do the reciprocals. Let's work our way back out of here. What would cotangent of 30 degrees be? Well, it would be the reciprocal of the square root of 3 over 3. But what was the square root of 3 over 3 before we rationalized it? It was 1 over the square root of 3, right? So what's the reciprocal of 1 over the square root of 3? Square root of 3 over 1, which is just square root of 3. Yeah, very good. So guess what cotangent of 30 degrees always is? Square root of 3, yeah. Let's go out of here. What's the reciprocal of cosine? Well, it's secant. What's secant of 30 degrees? Well, what's the reciprocal of square root of 3 over 2? 2 over the square root of 3, which when I rationalize it by multiplying by root 3 over 3 becomes what? 2 square root of 3 over 3, yeah. Guess what secant of 30 degrees always is? 2 square root of 3 over 3. Yeah, absolutely. And then our last one here, we work out. We get cosecant of 30 degrees is the reciprocal of sine. If sine is 1/2, the reciprocal of 1/2 is 2. Guess what cosecant of 30 degrees always is? 2. 2. Yeah, buddy. All right, so we just did A, B, and C, and we added some extras to it. Yeah, we did A, B, and C. We just added some extras to it. Oh, no, not quite. I'm doing this a little bit differently than the notes. Just forget about what these questions are asking. We're just going to walk through all of them. Okay? Yeah. Make a new space here. I need to redesign my notes. I don't like what I did. Okay. Everyone good on 30 degrees?
Yes.
These values are going to find their way to the unit circle soon enough. Because really, that's what we have, right? The radius is 1. So if I were to continue this radius all the way around, it would make a circle whose radius is 1. And of course, it's centered at the origin, right? So these values are part of what we're going to call the unit circle. So this is what's going to happen eventually. You're going to have 10 minutes on the very first one to answer 10 of these questions. One of the questions might be, what's cosine of 30 degrees? And guess what you're going to put after that? Square root of 3 over 2. I might ask you for the cosecant of 30 degrees, and you're going to put what? 2. Yeah. I might ask you for the tangent of 30 degrees, and you're going to put what? Square root of 3 over 3. Yeah. You're going to have 10 minutes to do 10 problems. That's a minute apiece. Do you have time in a minute to draw your little triangle and then pull the ratio off of it? Maybe, maybe. But we're going to work down to 10 of them in 3 minutes. Every day we're going to make the time be less and less. 10 questions in 10 minutes, 10 questions in 8 minutes, 10 questions in 6 minutes, 10 questions in 5 minutes, 10 questions in 3 minutes. Oh. Well, hopefully we can put a little flavorful seasoning on your nightmare and make it into a dream come true. All right. Let's take the same triangle, the 30, 60, 90, and let's just flip it and rotate it so that the 60-degree angle is the one that's on the bottom now. Let's make this the 60-degree angle and this the 30-degree angle, okay? And then, of course, we'll center the 60-degree angle as the central angle at the origin. So now there's no doubt to us what the reference angle is. You see that? The reference angle is 60 degrees. Let's go ahead and list the side lengths, okay? What is the side length opposite the 60 degrees in our new triangle? It's the square root of 3 halves, isn't it? So I'm going to label this as the square root of 3 halves. That's my y value. And then my x is going to be 1/2 now. And then my radius is still 1. Now, this should be easy to remember. It's the same numbers. We're going to be using the same numbers. You know why? It's the same triangle. It's just rotated. But now at 60 degrees, we're rotating quite a ways up. It's closer to 90, isn't it? So now what do you know about your triangle width versus height?
It's wider. No, it's taller.
It's taller than it is wide. It's taller than it is wide. Y'all see that? So the sine, the y, the height, should be the bigger of the two numbers now. Guess what the sine of 60 degrees is? Square root of 3 over 2 over 1, which is just square root of 3 over 2. Yeah. Guess what the cosine is now? It's 1/2 over 1, which is 1/2. So they switched places, didn't they? They switched places. That's why it's so important to know. 30 degrees is a shallow angle. It's wider than it is tall, so the cosine is square root of 3 halves, and the sine is 1/2. Now at 60 degrees, it's taller than it is wide, so the sine is the square root of 3 halves, and the cosine is 1/2. Got it? Orale? What's tangent of 60 degrees? Well, let's go to the triangle. Look, it's y over x. Square root of 3 over 2 divided by 1 over 2. What's going to happen with the 2's in the denominator? They're going to divide out, right? So it's just going to end up being the square root of 3 over 1. The 2's are going to divide out. So it's just going to be the numerator of the y divided by the numerator of the x. What's the square root of 3 divided by 1? Square root of 3. Guess what tangent of 60 degrees always is? Square root of 3. Hey, that was the cotangent of 30 degrees, wasn't it? You mean to tell me that the tangent of 60 degrees is the same as the cotangent of 30 degrees? That's what I'm telling you. Hey, what's 30 plus 60? 90. What do you call two angles that add up to 90 degrees? What? Complementary. Very good. Two angles that add up to 90 degrees are complementary angles. Guess what the co stands for in cotangent? Complementary. Tangent and cotangent are called complementary functions because they have the same trig value at complementary angles. Let's round it out here real quickly. What's cotangent of 60 degrees? It's the reciprocal of the square root of 3, which is 1 over the square root of 3, or when we rationalize, square root of 3 over 3. Okay? What would be the secant of 60 degrees? Well, it's the reciprocal of a half, which is 2. And what would the cosecant of 60 degrees be? Well, it's the reciprocal of square root of 3 over 2, which when we flip it and rationalize it, is 2 square root of 3 over 3. Woo! Woo! We're developing the unit circle values. So when we get to the unit circle, you're going to know where they come from. They don't come from France. They come from your special right triangles. All right, tomorrow we'll look at the 45 degree angle after your quiz. You're going to have 2 clues quiz tomorrow question. 1. And then we're going to move on to the notes. Y'all have a fantastic rest of the day. I hope to see most of y'all at the pep rally, but I don't know if he's going to choose seniors and juniors or seniors and sophomores. We're not all going to be together. That has me bummed out. But he's going to pick and run, and I hope it's y'all. I hope to see y'all there. And if y'all are there, please help me out by being loud and crazy.